computer's processor and graphics card are often seen as its most powerful components, but by themselves, they're silent and isolated. They require a foundation that provides not just a physical connection, but critical pathways that allow data and power to flow. This foundation is the motherboard, and in today's video, we're going to be covering this essential piece of hardware, understanding its role as the PC's central nervous system, and see why it truly defines what a computer can do. Let's get started. So what is a motherboard really? Well, on the surface, it's a large printed circuit board, or PCB. But it's not just the surface, it's a complex, multi-layered sandwich of fiberglass and copper pathways called traces. Think of these as a meticulously planned city map. Every component has its own address, and these traces are the roads, highways, and tunnels that let them all communicate. It can also be thought as the central nervous system that provides not only the physical connections for every part, but also the crucial electrical pathways that deliver power exactly where it needs to go. Now, motherboards aren't a one-size-fits-all component. They come in standardized sizes called form factors, which determine the board's physical dimensions and what kind of computer case it will fit into. The most common size you'll see is ATX. This is the full-sized standard that offers a great balance of features and expansion slots for most people. For a larger enthusiast PC, there's eATX. Going smaller, you have micro ATX, which is perfect for more compact computers, and for the smallest systems, there's mini ITX, designed for maximum space efficiency. Now, we're going to be taking a detailed look at a board today, and it can look intimidating, but understanding these parts is key to understanding your entire computer. Now, before we even look at the sockets, we have to talk about the chipset. The chipset is the motherboard's own traffic controller and data manager. It dictates what generation of CPU the board can use, what speed the memory can run at, and how many high-speed devices can be connected at a time. When you choose a motherboard, you're really choosing a chipset first. For example, on the AMD side, you might choose an AM5 motherboard with an enthusiast X870E chipset or a mid-range B850. For Intel, you might choose a motherboard for an LGA 1851 CPU with a Z890 chipset for overclocking, or a B860 chipset for a standard build. This matters because the higher end chipset will give you more features, like more M.2 slots for faster USB ports, so it's the true core of the motherboard's capabilities. Now, let's take a look at a board and see where all the components go. Our tour will start at the throne, the CPU socket. This is typically where the processor is installed. As we said, the chipset determines the socket, like AM5 for newer AMD processors or an LGA socket for Intel. Why this matters is simple: there is zero cross-compatibility. For Intel CPU will not fit in an AMD socket, period. Next, we'll look at the components surrounding the socket. These are the VRMs, or voltage regulator modules. These are covered by large heat sinks. They provide clean, stable power to the CPU, and boards with more robust VRM design can deliver that power more efficiently and with less heat. This is crucial for running high-end CPUs at full speed, and it is absolutely essential if you ever want to go into overclocking. And of course, the whole board needs power. This large 24-pin connector is the main source. This dedicated 8-pin CPU power connector gives the processor the extra stable power it demands. Now next are the RAM slots. This is where short-term memory goes. Why it matters is twofold. First, the motherboard determines the type and maximum speed of RAM you can use, like DDR4 or the newer DDR5. Second, for the best performance, you need to install RAM in a specific way to enable dual channel mode. This is the key time to check your manual. The manual will have a clear diagram showing exactly which two slots to use. These long slots down here are your PCIe slots for expansion cards. Now, not all expansion slots are the same. The top by 16 slot is almost always wired directly to the CPU and is the fastest. This is where your graphics card must go. Other slots are often connected to the chipset and might be shorter or run at slower speeds, perfect for other devices like Wi-Fi cards, sound cards, or capture cards. The chipset also determines the PCIe generation, like PCIe 4.0 or even faster 5.0. Moving on to storage, you have your SATA ports for traditional drives, but for primary storage, you'll use what's called M.2 slot. M.2 slots are much faster than others. The faster ones, called NVMe, use PCIe lanes for direct line of communication to the CPU. And again, consult your manual, as it will tell you which M.2 slots are the fastest, and if you're using one, might disable some of your SATA ports, which can be a common configuration. Now, let's talk about the software that lives on your motherboard. This small chip here is the BIOS chip. BIOS stands for Basic Input and Output System, and it's the first thing that runs when you power power on your PC. Its job is to wake up all of your hardware, check that they're working, and then tell the computer to load your operating system. Modern versions are called UEFI and have a friendlier graphical interface. Next to it, you'll find this little silver battery. This is the CMOS battery. Why it matters is that it provides constant power to the chip that stores your BIOS settings, like the system time, date, and your boot order, even when the PC is unplugged. If your computer ever starts forgetting the time, a dead CMOS battery is the likely culprit. On many boards, you'll also find this handy Q code reader. When the BIOS is starting up, this display shows codes for each step. This can let you know if your PC fails to boot, it will get stuck on a code, which you then can look up in your manual to see exactly what's wrong, turning a mystery into a solvable problem. And finally, you have all the connectors. The internal headers for your case fans, USB ports, and power buttons can be tricky. The front panel headers for your power button are a cluster of tiny pins, and the manual is absolutely essential here to know which pin does what. The rear I/O panel is your external connection hub. This helps dictate your built-in connectivity, how many USB ports you have, how fast they are, and whether you have features like built-in Wi-Fi. So we've went over a lot, and you're probably asking yourself, why does all this matter for everyday use? Think of choosing a motherboard like choosing the foundation for a house. It dictates everything else you can build on top of it. The quality of the power delivery, those VRMs we talked about, directly impacts your PC's stability and potential for high performance. A better motherboard can mean a more reliable computer. The number of slots determines your upgrade path. A board with 4 RAM slots means you can easily add more memory later. A board with only 2 means you might have to replace what you already have. The number of M.2 or SATA ports directly limits how many storage drives you can install for your games and files. Now let's put this all together and trace a simple action. You click a game icon, that signal travels from your mouse through the I/O panel. It is then routed by your motherboard to the CPU, which then fetches data from a drive connected to a SATA or M.2 port, which then loads it into RAM and works with the graphics card in the PCIe slot to display your game. The motherboard is the tireless manager in the center of it all, ensuring every component works together seamlessly. Your choice of motherboard defines the limits, the potential, and the reliability of your entire system. So as you can see, the motherboard isn't just another part. It's the computer's foundation. It lets us know what components we can use, how well they're going to perform, and what our future upgrade path looks like. And if you found this video helpful, please leave a like, comment, and subscribe to the channel if you'd like to see more content like this. Thank you so much for watching, and as always, keep growing.